Have you ever imagined yourself flying among countless sparkling stars, suddenly facing a dark abyss, a cosmic black hole? A region in space where even light cannot escape, where time stretches in bizarre ways, and gravity is so intense that everything is crushed. Now imagine you're piloting a spaceship slowly approaching the event horizon, the ultimate boundary that once crossed, no one knows what happens. Will you survive or disappear forever into endless darkness? Join me on this thrilling journey to explore the unimaginable mysteries of black holes. From deadly challenges to bold scientific theories that seem like science fiction, is there any chance for humans to survive and explore inside a black hole? This extraordinary and perilous voyage begins now. Are you ready to step into the gateway of immortality and mystery? Let's explore together. Before entering a black hole, the most important concept to understand is the event horizon, an invisible boundary where the familiar laws of physics begin to break down, and nothing beyond this point can escape. The event horizon is not a physical wall or curtain, but a limit in space-time dividing the outside universe from the interior of the black hole. It marks the point beyond which light cannot escape. As your spaceship slowly approaches the event horizon, you begin to notice distinct changes in your surroundings. Your onboard clocks tick normally, time feels regular to you. But looking outside, you see light and images stretching and slowing down, almost freezing. To an outside observer, it appears that you move slower and slower, practically freezing at the edge of the event horizon. This phenomenon is called gravitational time dilation. It happens because intense gravity slows time relative to an observer in a weaker gravitational field. At the event horizon, time for an outside observer seems to stop for you. Light no longer travels in straight lines, but bends and twists around the black hole. Stars and galaxies outside appear warped, stretched into thin streaks, twisting and fading as they are sucked in. You feel space around you warping and contracting, making it impossible to distinguish directions. Space-time around the black hole stretches dramatically. Gravity pulls everything inward and distorts space and time. Every path your spaceship takes is bent toward the black hole's center. Even light cannot escape. Sensors detect massive gravitational waves like ripples on a cosmic pond. Space-time itself appears distorted, and communication signals weaken or drop out. According to Einstein, space and time form a single fabric, space-time. You can imagine it as a stretched sheet, with the black hole acting as a heavy object. Pressing down, warping the sheet, objects around roll inward toward the depression, similar to balls rolling toward a dip. As your ship nears, space-time warps so intensely, you lose sense of up and down. Time inside your ship flows normally. But for outside observers, your journey slows to a crawl, seeming eternal. You and your crew feel growing tension as you approach the event horizon. Physical and psychological pressure builds. Instruments record strange phenomena, light shifting, energy surges, subtle space shifts. You realize every decision could be life or death. A single miscalculation could trap you forever. You may have heard of the phenomenon called spaghettification, a name that sounds both humorous and terrifying, accurately describing one of the strangest physical effects in the universe. As your spaceship ventures deeper into the black hole, you won't just face the immense gravitational pull, but also confront another challenge: tidal forces. These forces can stretch any object, from a small rock to the human body, into long, thin strands, much like spaghetti being pulled apart. To understand why this happens, imagine you are standing near a river. One of your feet is in fast-flowing water close to the source, while the other foot is in slower-moving water downstream. The force of the water acting on each foot is different, pulling the foot near the strong current much harder than the other, stretching you apart. Similarly, in the space around a black hole, the gravitational field is uneven, meaning the pull on the side closer to the black hole is much stronger than on the far side. This difference causes the tidal forces that stretch your spaceship and everything inside it. You will start to physically feel the deformation bit by bit. At the front tip of your spaceship, the part closest to the black hole, the gravitational pull is much stronger than at the tail. This stretches the ship lengthwise while simultaneously compressing it sideways. The crew may feel as if they are being pulled apart, with their bodies and everything around them being distorted along the length. If you have ever imagined a person being stretched into a long, thin noodle in a sci-fi movie, this is the terrifying reality. This phenomenon is called spaghettification, the distortion of matter into long, thin strands resembling spaghetti. As you go deeper into the black hole, tidal forces become so extreme that even the cells in your body cannot retain their shape. Everything is stretched out thinner and thinner, becoming extremely fragile and eventually crushed completely. The big question is there any way to survive tidal forces and spaghettification? According to modern physics, the answer is very difficult. The gravitational force at the event horizon and inside the black hole is so strong that any object will be stretched and destroyed. But there are still science fiction hypotheses and future technologies that might change this. In science fiction scenarios, spaceships might be equipped with special force fields capable of maintaining the internal structure of matter against stretching. These force fields would act like invisible armor, preventing bodies from being pulled apart and protecting the crew from extreme tidal forces. Some hypotheses also suggest that spaceships could adjust their speed or trajectory to minimize tidal force effects. Additionally, gravity control technology, if developed in the future, could help regulate the stretching forces inside a black hole. By creating opposing gravitational fields, a spaceship could balance tidal forces and maintain its physical shape. These are ambitious ideas, still theoretical, but they open the door for deep black hole travel in the future. Besides physical challenges, the crew will also face enormous psychological pressure. The sensation of being stretched, losing control before a colossal gravitational force would cause panic, fear, and even despair. Only unity, knowledge, and advanced technology can help them remain calm and maintain their will to survive. Before beginning the journey into the black hole, the crew must prepare carefully. Study the gravitational parameters around the black hole. Equip tidal, force measurement devices, and simulate effects. Plan flight paths in detail to avoid zones with the strongest tidal forces. Train survival skills and coping mechanisms in extreme pressure environments. Tidal forces and spaghettification are the harshest challenges when entering a black hole. While modern science has yet to find a way for humans to survive these forces, future technology hypotheses still offer hope. The next part will take you deeper inside the black hole to the mystery of singularity and the gateways of space-time, wormholes. After overcoming the harsh challenges of tidal forces and spaghettification, you enter the core of the black hole, a place hiding a mystery that scientists have yet to fully explain. The singularity. Singularity, also known as the point of infinite density, is the center of the black hole where matter's density becomes extraordinarily high, and the physical laws as we know them seem to completely break down. You can imagine the singularity as an incredibly tiny point that contains the entire massive weight of the black hole. Here, gravity becomes infinite, and space-time bends beyond measurement. At this point, modern physics, including Einstein's theory of general relativity, can no longer accurately describe what happens. Scientists often call the singularity the final mystery of the universe. No one knows exactly what happens inside the singularity because there is no way or technology to observe or measure it directly. It is also the point where our current laws of space, time and matter cease to apply, opening the door to countless hypotheses and speculations. One of the most fascinating hypotheses about the singularity is that it might not be an endpoint, but rather a gateway to a wormhole, a tunnel through space and time. Wormhole is described as a bridge connecting two distant points in the universe, or even between parallel universes. If this hypothesis is true, the singularity isn't a deadly trap, but a door leading to completely new and unexplored worlds. Imagine your spaceship passing through the singularity and entering a brightly glowing wormhole where space and time twist into a luminous tunnel. This would open the possibility to travel to other universes or even to different points in past and future time. If harnessed, wormholes could usher humanity into an era of space travel beyond all current limits. Despite their allure, traveling through wormholes is not simple. Scientists warn that wormholes might be highly unstable and could collapse at any moment, crushing anything inside. Moreover, to keep a wormhole open, it may require a special type of matter called exotic matter, with negative energy, something humanity has yet to create or control. Although still hypothetical, these ideas present a hopeful vision for the future. One day we may develop technology to surpass singularities, control wormholes, and step into new universes or times. The journey into a black hole might not be the end, but the opening of a mysterious, infinite new cosmos. Singularities and wormholes represent the pinnacle concepts of modern physics and science fiction. They challenge the boundaries of our understanding and invite relentless exploration. The next part will explore modern scientific experiments, discoveries, and emerging technologies that bring us closer to unraveling the mysteries of black holes. Let me know if you want me to prepare mid-journey prompts for this part or continue with the next. Until a few decades ago, black holes were only abstract concepts in physics equations, mysteries that humans could only imagine in books. However, with advances in technology and science, we have begun to actually see black holes, feel their tremendous power, and even detect signals from events occurring around them. In 2019, humanity entered a new era with the first real photograph of a black hole. The image of the black hole at the center of galaxy M87, more than 55 million light-years away, was captured by the global network of telescopes called the Event Horizon Telescope, EHT. This photo not only provided visual proof of black holes, but also confirmed Einstein's theory of general relativity, showing a dark central shadow surrounded by a brilliant glowing ring, the luminous accretion disk of matter. In 2015, the scientific world was shaken by the first detection of gravitational waves by the LIGO Observatory. Gravitational waves are ripples in space-time caused when two black holes spiral into and collide with each other, releasing a tremendous burst of energy. This discovery not only further proved the existence of black holes, but opened an entirely new way to hear and see the universe through gravitational waves. Since then, dozens of black hole and black hole neutron star collisions have been detected, helping us better understand the evolution of galaxies. One of the most famous theoretical discoveries about black holes comes from physicist Stephen Hawking, who proposed the theory of Hawking radiation. According to this, black holes are not completely black, but emit faint radiation due to quantum effects near the event horizon. This raises a major question known as the information paradox. Does information about matter falling into a black hole disappear forever? Research and debate on this paradox continue to be a hot topic in theoretical physics. Recent studies show that most large galaxies harbor a supermassive black hole at their centers. These supermassive black holes are not just gravitational centers, but significantly influence the formation and evolution of their host galaxies. Energy outbursts from these black holes can trigger or suppress star formation, shaping the galaxy's structure. Advances in telescope technology, quantum computing, and particle physics bring us closer than ever to understanding black holes. Projects like the upgraded Event Horizon Telescope 2.0, next-generation space telescopes like the James Webb Space Telescope, and future gravitational wave detectors will provide more precise data, helping uncover the deepest secrets of black holes. From the first images to gravitational wave detections and groundbreaking physics theories, black hole research is opening new doors for science and cosmic exploration. We are not just observing anymore. We are gradually understanding how these colossal cosmic machines operate. The next part will explore hypotheses about humanity's future and the possible roles black holes may play in expanding the boundaries of space and time.
As you've seen throughout the journey into a black hole, we face a series of terrifying and nearly impossible challenges. A black hole is not just a mysterious phenomenon, but a severe test of the limits of physics and life. We began by confronting immense gravitational forces, strong enough to bend space and time, pulling matter inward where it can never escape. Light itself, even, cannot escape the boundary of a black hole, known as the event horizon. This raises the question, can we survive a journey into a black hole? The current answer, based on what we know today, is a firm no. Tidal forces would stretch your body into long strands, much like the phenomenon of spaghettification seen in science fiction movies. What you would experience in this extreme environment is horrifying, potentially destroying any object, including humans. But that's not all. After facing those physical challenges, we encounter singularity, where space and time completely break down. This is the point at which all the laws of physics as we know them no longer apply. Why? Because singularity is the place where all our physical laws become obsolete. We cannot measure or even begin to understand what happens at this point in the universe. These immense challenges make us ask a bigger question. Is there any chance for humanity to survive all of this? But while we may not be able to survive a journey into a black hole today, this does not mean all doors are closed. While these challenges may seem impossible to overcome with current technology and understanding, science is evolving every day. We haven't yet explored the full potential of the universe. The future of humanity may very well be defined by completely new technologies, discoveries that will change how we perceive space, time, and even life itself. Surely theories about wormholes or special fields of force could be the critical advancements that help us overcome these challenges. If these theories about force fields and space-time manipulation are accurate, we might not just survive, but safely travel into black holes in the future. Moreover, advances in quantum physics, quantum computing, and new generation space telescopes, like the James Webb Space Telescope, could help us gain deeper insights into the nature of black holes. With these advancements, we may not only observe black holes, but also potentially interact with them in the near future. From what seemed like a hopeless scenario, we now begin to imagine a future full of promise, where journeys into black holes may no longer be an impossibility. Modern science is approaching key milestones, discoveries that could help us unlock new doors in the universe. This won't just change how we understand the cosmos, but also provide a stepping stone for humanity to expand the boundaries of space and time, travel across parallel universes, or even move through time. In the near future, as new technologies develop, we could see ourselves passing through wormholes or entering new dimensions, exploring places that no one could have ever imagined before. And perhaps one day a journey into a black hole will transform from a deadly venture into a scientific journey of discovery. The universe isn't an end, but a beginning of endless inventions and exploration. The discoveries of black holes, the universe, and the mysterious phenomena of space are not the end of the journey, but just the beginning. The path opens up, countless questions yet to be answered and inventions that will shape humanity's future. If you love exploring the mysteries of the cosmos, these bold scientific theories, don't forget to subscribe to our channel and stay tuned for our next exciting video. We'll continue this journey together, from fascinating theories to promising experiments, unlocking new frontiers in space exploration and other scientific wonders.